savings, plans, and investments. So if you want to pause this video at this very moment just to write down the helpful information written in blue and red, I would do that. We're going to use that formula. Now let's move on to our first application problem. It says use the savings plan formula to calculate the following. We have a savings balance after 6 months for an APR of 12% and monthly payments of $100. So if you notice that we're going to be talking about per year, so we need to write the 6 months in a format of years. So I know that 6 months is divided by 12 months times 1 year gives me what? 0.5 years. And this is what we need to use to factor in that place for y. Y equals, okay? And it may be time. We could double check. Sometimes it uses y, sometimes it uses time. It's still using y. All right. Now, we know what R is. R is this 12%, but we need to write it in decimal, right? So we get 0.12. And P is going to be what we deposit each month. So let's calculate this. So it's going to be a little bit of a lot of writing. I say a little bit of a lot of writing, but it's going to be. Got to be careful. If you write this stuff down multiple times, make sure and watch and not typo or transpose a number. So it's compounded. Oh, and let's talk about it. It said monthly payments. So we're at my N, I need to acknowledge that, is 12. So now I have 12 times at 0.5. Let's come over, minus 1, all divided by. All right, so now I have everything plugged in this formula. Here's the thing. Some of your calculators may allow you to type the whole thing in exactly how you see it, and it gives you the answer. Some of you are going to have to use like multiple parentheses. So I'm going to just encourage you, if you don't have the calculator that allow you to type it out, and I really encourage you to be able to do this on your own without having used the calculator, but there may become a point when we're raising it to the 12th power, times 0.5, we need the calculator for it. As if not, we're going to be calculating all day. So now let's say 1. So let me tell you what I'm working on first. I'm computing this here first. Well, first I want to do, let me get this right. So first I want to do this part. Second, I'm going to raise it to this power. Third, I'm going to subtract 1. And that's what I'm going to put right here. Okay. And then fourth, I will come and do the denominator and put it here. Okay. And that's how I'm going to do it. So I got 1 plus that fraction, which is 0.12 divided by 12. And we're going to raise that to 12 times that 0.5. And then I'm going to subtract 1. So now in my numerator, I get 0.0615201,506. And my calculator stopped and rounded here. Some of y'all may round a little sooner or a little later, but I'm not going to round until the very end. So I'm going to use what my calculator gives me. So then I'm going to take that 0.12 divided by 12, and it gives me 0.01. And guys, I like to put a 0 in front of my decimal if I don't have any other number to go there. All right, so now I'm going to say 100 times that fraction, 0.0615201,506 divided by 0.01. And it gives me 615.20. $615.20. Okay. Now let's do the next one. The next one says the savings balance after 5 years for an APR of 2.5% and a monthly payments of $100. I feel like you can do this one on your own. So if you want to pause this video, calculate it first, and then turn it back on to make sure that you got it down, I strongly encourage you to do that. So first, let's acknowledge what is 5 years. 5 years is Y. Well, hang on, we'll get to it. R is going to be the percent, which is 0.25%. We're going to write it in decimal form. N is going to be 12 because we're talking monthly, and then P is my 100. Let's plug it in my equation. Okay, I'm almost done. All right, so we're good. Now, what are we going to do? We're going to compute these things, right? So let's do it the way I did before. Let's go ahead and say, okay, I want to first do this parenthesis. And then next, I'm going to raise it to its power. And then third, I'm going to subtract 1. And that's what's going to go here in the fraction. And then fourth, I will do this denominator. Okay, let's do it. So I got 1 plus that fraction. I'm going to raise it to the power of 12 times 5, which is 60. And then I'm going to subtract 1. So now we have okay, and then the denominator, we got 0.025 divided by 12. It's going to give us oops, kind of got carried away with my 3 there. 0.00283333, repeating. So now I'm going to go ahead and say 100 times that fraction, 0.1330012. 8. Oh my, so my writing was terrible. My apologies, guys. On the writing part, we have to really watch that. So it happens even it happens to everybody, okay, guys? So if it happens to you, don't get too hard on yourself. Just take it as a learning moment and try not to let it happen again. Okay, so that was 219. There we go. All right, so now got 100 times that fraction. I know it's there at the end of a very long decimal, but you know, I don't want to be off by a hundredths or a thousandths of a point because it can cause our answer to be wrong. All right, so I came up with, I'm going to double check my math right quick because my answer, I came up with something different that time than I did the time before I did this. So it doesn't hurt to always check your math, okay? So I'm going to do this right quick. And I encourage you to do it too. Okay, yes, it's very good. So I need to come back and check my decimal numbers that I got. And this is my answer I got, 6,384.5 cents. So definitely, I encourage you to. So my top number is correct. Let me check my bottom number. And it's correct. Oh no, I know what I did wrong. I typoed. So it happens. I'm not saying that I'm excusing myself. I'm just saying it happens. It was a 0 between the 2 and the 8. Okay. So that makes a big difference in my answer because without that 0 between the 2 and the 8, I got 4,000 and something. And then when I realized that something was not right with my numbers and I went back and redid it, I lost, I mean, that's almost $2,000 difference. So definitely check your writing and the numbers you're working with. All right. So let's do our next one. It says at the age 30, Michelle starts an IRA to save for retirement by depositing 100 at the end of each month. If she can count on the APR of 6%, how much will she have when she retires 35 years later at the age of 65? We're going to compare the IRA's values to her total deposit over the next time period. This here is great because I strongly encourage everybody not only to have a retirement. You can't trust in someone else to give you the money when you retire, but also create your own little nest egg where you're saving your own money. Because we just never know, what's going to happen in the future. Plus, you may need something or your family or something. And if you have a nest egg saved up and it's growing on the side, then if you ever needed to go to it, it's there. So I strongly encourage to save this. So I really enjoy this section because I feel like it teaches you this. All right. So I'm done talking. Sorry. Let's get back to solving. So let's acknowledge what is our principal. Our principal is the 100 that we're going to deposit. All right, let's plug in our formulas. So what is our interest? Our interest here is going to be 6%. Let's write it in decimal form. And by this point, hopefully you understand how to convert 6% to decimal. If not, divide it by 100% or move the decimal 2 places to the left. How is it compounded? Well, it's monthly. It's set in month. So n is 12. So we're going to raise it to 12. And it said how many years? It said 35. And then I'm going to subtract 1. And we're going to, and then our denominator is going to be the interest, the APR, divided by the 12 months. All right. So let's do this. And let's do it in steps, just in case we have a typo. So I have 1 plus that fraction, 0.06 divided by 12. I'm going to raise it to the power of 12 times that 35. And then I'm going to subtract 1, and I get 100 times this fraction, which is 7.1235. 51494. And then the denominator is 0.06 divided by 12. And we get 0.005. And let's type it in our calculator. 100 times that fraction. And let's see what we get. I get 14,200. Oh, I said that wrong. $142,471.03. Guys, if you use a decimal, make sure it looks like a decimal when you're writing and not a decimal, excuse me, a comma. If you use a comma to separate that, because it helps you to read it out. I read out 14,000, my calculator will do the comma. But it took me a minute to realize, oh, hey, there's 6 digits in front of that decimal. If you choose to use it, make sure it looks like it when you're writing and submitting your work and it don't look like a decimal. So a comma You know, we get a little sloppy. I do anyways in my writing. So just be careful with that. Okay. So we know that $142,471.03 is what she could have in her IRAs at the end of 35 years when she's 65 years old. Is to compare the IRA's value to her total deposit over the time period. So her total deposit, what if all she did was deposit $100 each month for 35 years? How much money would she have then? So 100 times 12 times 35 is $42,000. Hey guys, $42,000 is great. But when I compare it to that $142,000, I'm like, oh my goodness. The better deal would be if I can invest it at a 6% over that period of time and continuously deposit that $100. That's if nothing changes. So that's something to think about. Okay, so let's move on. You want to build a $100,000 college fund in 18 years for your newborn. By making regular end of month deposits, assuming an APR of 3%, calculate how much you should deposit monthly. How much of the final value comes from the actual deposit and how much from interest. All right, so I'm gonna give myself some space right here, just a little bit. All right, so the monthly deposits, how much are we gonna have to deposit in order to acquire that 100,000 at the end of 18 years when the child goes to college? So when I set up my formula, I got A, but I don't know what P is. I don't know what the principal is. I know Y is 18 years. I know R is my 3%, which I'm going to write it in decimal form. And it said monthly, I believe, yes, end of month. So I know N is 12. So I'm going to take that 100,000, set it equal to the P, and then have all this here. Like I said, there's multiple ways to do this, to solve for P in this format, but I'm going to get this all into a number and then divide it instead of just trying to carry the whole thing, because it's a lot of writing. So my APR is, again, 0.03. My N is 12. We're raising it to 12 times 18. We're going to subtract 1. My denominator has 0.03 divided by 12. Now, again, I just want to, guys, if you need to use a comma there to help you, I would. My comma looks terrible, so I just did a space, but I shouldn't have done space. But anyways, let's get this all to a number. So I'm going to take 1 plus that fraction. I'm working on the numerator. I'm going to raise that to the power of 12 times that 18. I'm going to subtract 1. And then I'm going to divide it by my fraction. Okay. 0.3 divided by 12. All right. So this is what I get before, and I'm not rounding, okay? This is what I get before I get any rounding. And again, your calculator may round sooner or later than mine. I'm going to divide both sides by this parentheses, this bracket here. And you don't need it. Once you start moving it, you don't need the bracket. We only needed it when it had all that stuff involved. And some of you may like it because it just separated it from the P. So I'm going to divide both sides by that. All right. Now, P is equal to 100,000 to 85.9403496. Okay. So now I came up with, and I'm going to round to the nearest hundreds? $349.72. So I need to deposit no less than $349.72 each month in order to have my end go, right? So let's do this. $349.72 would be my deposit each month. And then I want to know my total deposits for the 18 years, how much I'm actually truly going to have. So for this one here, let me change this to, let's go to orange. So I'm going to take that 349.72. I'm going to times it by 12 months, times it by 18 years. And what does that give me? 349.72 times 12 months times 18 years. Gives me $75,539.52. Okay. So now I have that. That is just my payments alone. That's not counting the interest that it actually grew, right? So if I wanted to determine how much interest that grew during that time frame, I'm going to say, okay, 100,000 minus that 75,539.52. So I actually acquired an interest of $24,460.48. Not bad. Not bad. I'm going to let you do part B. So reach out to me if you have any questions. But definitely do part B and see what you get. We're going to move on. Example 4 says, would you like to retire 25 years from now and have a retirement fund from which you can draw an income of $50,000 per year forever? How can you do it? Assume a constant APR of 7%. Well, let's figure that out, right? I mean, this is what we want, right? So we need to, okay, there's an extra step we got to do here. So first things first, we have an APR of 7%. We're going to write that in decimal form and let's get started. Let's say I have 0.07%. I'm going to put X back because it's my unknown. I'm going to set that equal to my 50,000. I'm trying to figure out what I need to, what would my end goal be, right? So that I can do this. So I'm going to divide this by 0.07 because I need a coefficient of 1 on my X. And it's not just 1, my apologies, a positive 1. So now what I have 50,000 divided by the 0.07. And that gives me, let me put an approximation somewhere around 714,285.71. Okay, so this is something I'm going to work with. I'm going to take this number and I'm going to actually, and if you wanted to call this A, you could have, because this is my A value. It's my end goal value. So I'm going to go ahead and say A here. All right. We know this is R. We know that this is Y, right? Let's write it in. We're trying to figure out how many payments too. So I'm going to take this 714,285.71, set it equal to my payments. And then I got 1 plus my interest, which is 0.07 divided by 12 months because we're working on monthly. We got 12 times 25 because we want to retire in 25 years minus 1. All divided by the 0.07 divided by 12. So again, if you just want to move that whole parentheses, you can. I'm going to get it in a number form and then move it. So I have what? 1 plus that fraction, which is 0.7 divided by 12. I'm going to raise that to 12 times 25. I'm going to subtract 1. And now I get 4.725418209. And then denominator is 0.7 or 0.07 divided by 12 gives me 0.005833333 repeating. So now I got 4.7254818209 divided by 0.00583 repeating. Okay. So now I'm going to bring this down to 714,285.71 equals the PMT of 810.071696. And I'm going to divide both sides by that number. Oops, that should be a 976. I gotta watch my writing. All right. So now I have my payments is equal to I'm going to round to the nearest hundreds, 2 decimal places. Okay, that's my payment that I have to make each month. It'll be my investment each month. All right, so now let's figure out how much that would be. So I got 881 times, right? $881.76 times 12 times 25. All right, 12 months times 25 years. So that means I'll have 264,528 that I've made in payments, dollars wise. And then I can subtract that from the 714. Here, I'll write this down. And then we're going to take that. So we have our 714 or INGO, right? I'm going to subtract that 26. Let's line it up better than that. Not 8, 2, 5, 4, 6, 2. So 714,285.71 minus 264,528. And that gives me 449,757.71. That's a good chunk of interest. I actually drew more interest this go around than you had to pay in. So, I mean, that's really good. Okay, so let's move on. Okay, the next section, if you want to take a minute to pause it so you can write this down, we're going to talk about annuals and returns. This information will be helpful in the formulas we're going to use. All right. So this next example says you invest $3,000 in Clearwater Mutual Fund. Over 4 years, your investment grows in value to $8,400. What are your total and your annual returns for 4 years, period. All right, so let's solve for it. On the annual return, AP, we're going to take our 8,400, divide it by that 3,000, and we're going to raise it to, oops, let me fix this right quick. My writing kind of got a little sloppy. All right. We're going to raise this to the 1/4, right? It's 1 per year, 4 years. And we're going to subtract 1. And then we're going to multiply it by 100%. All right, let's do this. So I got my fraction, 8,400 divided by 3,000. We're going to raise it to the power of 1/4. And then subtract 1. And then multiply by 100%. And let's round 2 decimal places, okay? 29.36%. 29.36. All right, that was my annual return. What is my total return? So let's do the total return. I'm going to call it TR. So I want to take the 8,400, subtract the 3,000, divide that by the 3,000, and then let's multiply it by 100%. Oops. Okay, I got 180% on the return. That's not bad. Let's look at B. B says you purchased shares in newweb.com for $2,000. 3 years later, you sold them for $1,100. What were your total return and your annual return? So we're going to do the same way, right? We're going to take the AP. We could call it annual AR. Let's call it AR. And I just got carried away with the P. I believe I wanted this one to be R. What to go to annual return. That's better. R for return. All right. Let's plug it in. And if you need to, oops. So I got 1,100 divided by the 2,000 raised to 1 per year. And what's the year? The year is 3 years. And then we subtract 1 from that and multiply it by 100%. So let's do that. A negative value here. And make sure I'm round to 2 decimal places. Got negative 18.07%. Negative's not good, right? All right. Now let's solve for the total returns. So we got the 1,100 minus 2,000 divided by 2,000, all times that 100%. Negative 45%. Negative's not good. Not if it's an investment for your, an investment that you're trying to gain from. Okay. You purchased a mutual fund for $8,000 when it matters. After 20 years, you receive $12,500. What would your total return and annual return be in the investment? I'm going to encourage you to do this one by yourself. Holler at me if you have any questions on it. If you want to take a minute to get this information down, we're going to talk about stocks, bonds, cash, liquidity, and then risk and returns. Let's get started on our next application. Oh, and I'll scroll up if you wanted to get that down to pauses. All right. So our next one says, suppose your great-great-grandmother invested $100 at the end of 1900 in cash of 3 funds that tracked the averages of stocks, bonds, cash, respectively. Assuming that assuming that the stock grows at 6.3%, bonds at 2%, and cash at 0.9%, approximately how much would each investment have been worth at the end of 2012? Oh, wow. Okay, so we need to determine how many years first. Let's just do that first, because we're talking about 2012 and we're talking about at the end of 1900. So if I took 2012, subtract that 1900, right? We get 112 years. I was double checking that. All right. So that's my Y. We are talking about 112 years. Now, if you need to, I would list this. We got stocks. And my rate here is 6.3%. I'm going to write it in decimal. We got bonds. That rate there is 0.02, which is 2%. And we got cash, which is a rate of 0.009. Yeah. All right. So now let's solve. When we started out, she started out with $100. So we have A is equal to 100 times that 1 plus my interest raised to 112 years. Okay. So 100. Okay. I'm doing it in steps just in case. Some of you are going to be like, I don't need the steps, and that's cool too. I'm going to go ahead and multiply that. Just make sure you get the same answer. If you have any issues, please just, or you get a different answer and you need help, just holler at me. I'm going to round again to the nearest 2 decimal places, the hundreds. We're talking about money here, so that would be my stocks. All right, let's do the bond. So we got A is equal to 100, 1 plus that 0.02, raised to the 112. And that gives me what, 100 times 0.02 raised to 112. We get, whoops. I'll put the dollar sign on. Just put the dollar sign on. That matters because it's money. All right, and let's do. Oops. We're plugging in that percent. And all right. So that would be on our cash. That would be great. The best one is the stocks, but it would be great if you had it in all of those accounts and then you add it all up. I mean, that's a good chunk of money that the great grandmother saved. Hey, our next section, if you want to pause this and take a minute to write this down, we're fixing to use that formula and we're going to the next section. All right. It says the closing price of a U.S. Treasury bond with a face value of 1,000 is quoted as 105.97 points for a current yield of 3.7%. If you buy this bond, how much annual interest will you receive? All right, so let's talk about our current yield, our CY, which is equal to AY or AI, excuse me, my annual interest payment divided by my CP, my current price of bond. Well, we know what the CY is. That's going to be my interest here. This is my CY, and we're going to write it in decimal. All right. And then we don't know what AI is, but we do know what our CP is. Our CP is going to be this times our points. So our CP is going to be 1,000 times our points. And let's talk about our points when, because there's a step here that's not showing. Our points is 105.97. And whenever we talk about points, we need to apologies. Let me see if I can explain this correctly to you. The points earned has a value on it. It's written in percent, right? So it's seen as a percent. Okay, so whenever I take those points, it means that the bond is selling at that percent. Okay, let me see if I can get this clearer. My apologies, guys. Oops. My mouse got carried away there. So the points of 105, let me turn my tablet, 0.97 is a percent of the bond. Okay, it means it's selling at that percent, has a face value. So if I take that percent, that 105.97, and multiply it to that 1,000, I'm going to end up with 1,059.7 or 0.70. So we are talking about money. So now that I have this as my answer, as far as the CP goes, and we know in order to take this out of percent, right, we have to divide by 100 or move the decimal 2 places in that direction. So that means I got 1,000 times at 1.0597. I'm hoping this makes better sense about my points. Okay, it's a percent of the sales of the bonds. All right. Now I'm going to rewrite this in a format that everything's plugged in except for what we don't know or unknown. Okay. So now that I've done that, I got this. Okay, we're good. Now we need to solve for the AI. In order to do that, I know that it's involved in the fraction. So I'm going to multiply both sides by the denominator to undo the fraction. So now I have AI is equal to let's do it. 0.037 times 1059.7. And that's going to give me 39. Let's put a dollar sign with it, 0.21. Because we're going to round to the nearest hundreds because we are talking about money. And that would be how much an annual interest I will receive on this account, right? B says, well, compute the current yield on a $1,000 US bond with a coupon rate of 2.5% that has a market value of $1,050. So we're going to do the same thing, except for we don't know what the current yield is here. Let's acknowledge, though, what each part is. We know that this coupon rate of that percent is going to be multiplied to that 1,000. It's going to give me what my AI is. So my AI is that 1,000 times that 2.5%. And again, you'll take that out of decimal. Or excuse me, take it out of percent, putting it in decimal. Okay, so let's go ahead and do that. It gives me 25. All right, so that goes here. And then my CP is that 1,050. So let's divide it out. 25 divided by 1,050 gives me, oh wow, gives me this really long decimal. And I'm going to multiply it by 100%. And I'm going to round to the nearest 2 decimal places, the nearest hundreds. Or you could say, instead of multiplying, we're just moving the decimal 2 places to the right. And then round. And there we go. There's our answer. All right, so I'm going to allow you to do C. I say allow you. I'm going to ask you to do part C and reach out to me if you have any questions. This next part, if you want to pause this here and read this information, we're fixing to go over this. Okay. As you see here on example 8, you are giving this image that came from the textbook. And we're going to apply this knowledge from this particular example here. Suppose you decide to invest $5,000 in the fund shown in figure 4.7. How many shares will you be able to buy? All right, so I'm going to take that $5,000 right here that I'm saying I'm going to invest. And then I'm going to look at that table, right? Let's look at this table here. And I probably need to make it a little bit bigger. Some of you probably have better eyes than me on this. But if you notice right here, this is what we're going to divide by, the 83.83. And then when we divide this, then that means we can buy 59.64 shares. Okay. Now you may have to, so we're going to use this again. So I'm going to scroll back and forth. It says that if you buy, or if you had invested $5,000 in this fund 3 years ago, how much would your investment be worth now? So what I'm going to do is I'm going to say, okay, I got my formula because this is a different type of question. I got $5,000 that I'm investing, and then I got 1. And let's go up there and let's figure out what is that interest that they're talking about. And it says, let's see, 3 years ago, right here, you see it? Right here, it's a negative 9.19%. So originally, this formula has a plus here. Well, I'm going to go ahead and put the plus. But we're going to take this 9.19% and write it in decimal. Okay, and we're going to raise it to 3 years. And I didn't give myself enough room here, did I? Okay, let's finish this up. So and I get $3,744.30. So I want you to try to do C on your own and reach out to me if you have any questions. And thank you for your time.